Welcome to 5.5 double angle identities. We're going to be on page 13 in our 5.3 and 5.6 note packet. And this video features Miss Weldon,
Miss Cadett, and Mrs. McFadden.
Okay, today's objective. You will be able to use double angle identities to rewrite and evaluate trig functions.
Ay, ay, ay. He's confused.
To do what?
All right, remember to have your Pythagorean triples written down. You'll need to know these for this section again.
Yes, so if you don't have them written down, write them down for the 4th day in a row.
Okay, so here's the formulas. So let's talk about the formulas a little bit at the top. We have sine 2 theta. Okay, if you look at the sine 2 theta, you need to know sine and cosine. Then we have tangent 2 theta. In order to evaluate tan 2 theta, we need to know the tangent of theta. On cosine 2 theta, we have options. So if the problem gives us a cosine and a sine, we'll use the first formula. If the problem gives us only a cosine, we'll use the middle formula. And if the problem gives us only a sine, we'll use the bottom formula. Okay, these are also on your green card if you need them.
Example 1. We want to use the double angle identities to find the exact value. So we're doubling an angle and we want to find the value of that doubled angle. We're given that sine of theta equals negative 12/13, and we know that theta lies between 3 pi over 2 and 2 pi. So theta, our angle, lies in the 4th quadrant. Notice the formulas that we have, the identities that we have. We have one that specifically only uses sine. That would be the bottom one. So we can simply plug negative 12/13 into that formula. We really don't even need to draw a triangle this time on our coordinate plane. So we start out 1 minus 2, open parentheses, sine, which is given, negative 12/13, close parentheses, squared. 1 minus 2, open parentheses. Now we're going to square the numerator and the denominator. So negative 12 squared is positive 144, and 13 squared is positive 169. Now we'll start at the beginning again, 1 minus, that's basically 2 over 1, so we're going to multiply 2 over 1 times 144 over 169. If we, 1 minus, if we multiply straight across the top, 2 times 144 is 288. And if we multiply straight across the bottom, 1 times 169 is 169. In order to subtract, we need to have a common denominator, so let's rewrite 1 as 169 over 169 minus 288 over 169. And we calculate 169 minus 288, and it equals negative 119 over 169. And that's our answer. That's the cosine.
Okay, for example 2, we're given cosine theta equals negative 4/5, and cosines between pi and 3 pi over 2. We're trying to find the sine of 2 theta. So let's look at our formula. For our formula, we need 2 sine theta cosine theta. So we're given cosine theta, we need to find sine theta. So this time we need to set up our triangle. Okay, so we're between pi and 3 pi over 2, so that's in quadrant 3. So we'll set up our triangle. Cosine is adjacent over hypotenuse. So negative 4 is our adjacent, and our hypotenuse is 5. Remember, your hypotenuse is always positive. So we need to figure out what is our missing number from our triple. This is a 3, 4, 5 triangle. We're in quadrant 3, so our sine is also negative, so we have a negative 3. Okay, so the sine of theta is -3 over 5. Okay, so now we'll just plug into our formula. 2 times -3 over 5, that's the sign, times -4 over 5. Okay, now we're just ready to multiply straight across. 2 times -3 times -4. So we have 2 times -3 is -6, times -4 is positive 24. Negative times a negative is a positive. Okay, then straight across on the bottom, we'd have a 1 on the bottom. 1 times 5 is positive 25. So our answer is positive 24 over 25.
Okay, on to example 3. It says, given cosine theta is -5 over 13, and pi over 2, theta is between pi over 2 and pi, find tangent of 2 theta. Okay, if you notice, tangent of 2 theta formula only has tangents in it, but this problem only gives us cosine. Okay, so we're going to have to use cosine to figure out what tangent is. Theta is between pi over 2 and pi, so theta is in quadrant 2. So let's draw on our triangle. Cosine is adjacent over hypotenuse, so adjacent is 5, hypotenuse is 13. Since we're in the second quadrant, we know that the 5 is negative, and our missing side length is 12 according to your Pythagorean triples. Now we can figure out what tangent of theta is so that we can plug this into our formula. Tangent is opposite over adjacent. Okay, the opposite side is 12. The adjacent side is -5. All right, now let's plug in. We have 2 times 12 over -5 over 1 minus 12 over -5. Okay. And don't forget to square this. All right, so if we look at, we're going to need a calculator for this because this gets a little messy. Okay, let's do the numerator first. Okay, we have 2 times 12 divided by -5. And that didn't work. There we go. Okay, hit enter, and we get -4.8. Divided by, now we have 1 minus 12 divided by -5 squared. Okay, hit enter there. So we have divided by -4.76. All right, now we need to divide these two numbers together. So we have -4.8. That didn't come out negative. There we go, -4.8 divided by -4.76. Okay, that's a really messy decimal, and we want to leave our answers as fractions. So math, enter, enter, and our final answer is 120 over 119.
Okay, next example is number 4. Use the double angle identities to find the exact value. Given cosine theta is 8 over 17, and theta is between 0 and pi over 2, we're looking to find cosine 2 theta. All right, so let's look at our formulas. We can choose sine minus, or cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Well, they give us cosine, so let's choose the one that only requires a cosine. So now we don't even need to set up a triangle. All we have to do is 2 times cosine, which is 8 over 17, squared, minus 1. Okay, 8 over 17 squared, remember, distribute to your numerator and your denominator, so that gives us 2 times 69 over 289, over 64 over 289, sorry, 289, parentheses, minus 1. Okay, multiply straight across. Okay, we're going to multiply straight across. 2 times 64 is 128. over 1 times 289 is 289. Need a common denominator, so we'll subtract 289 over 289. Okay, then we have a common denominator, so subtract your top. 128 minus 289 is negative 161 over 289, and we are done. So now that you've watched this video, we hope that you feel more like Einstein.
Instead of the guy in the beginning that was confused. Have a good day.